Hello, everybody. Let's debrief the exit ticket from today. The Monte Carlo problems you've been working on often involve displaying a table of values like this. And the values in the right-hand column come from the results of combining many experiments together. And when you combine the results of the experiments, you very often have to take an average or find a probability. And so the three questions here let you practice those things separately. Question 1 is displaying a table. Question 2 is calculating an average and then a probability. So if you want to follow along, I'm displaying questions without showing the answer, and you can try again on your own and then see the answer if you feel like that would help you. In this question, it says complete a data table that will display values from 10 up to 32, and then in the right-hand column, take whatever the input value is, square it, and add 1. So here's an answer. I've added a couple things to the student solution in green pen. The student wrote, start I from 10, as long as it's less than or equal to 32, continue to loop and add 1 every time. And that's perfect because that's going to get from 10 to 32. Inside the loop, we take a number and display it, and that's going to be the left-hand number. This \t makes a tab, but you could have just put spaces. That's okay. So we'll display the number and then some space, and then the number in the right-hand column is calculated by taking the initial number, multiplying it by itself, and adding 1. The reason that this was not correct the way that it was written is because here we're treating n like a variable, but there is no variable n in the student solution. Their loop counter was called I. So all I did was I defined a new variable n, and it's a little bit silly to do this. I assigned I directly to n. Probably better than that would have been to just change all these n's to be i's. So take the variable that is already your loop counter and use that to calculate all the things. The other addition I made is displaying this first row in the table, which only displays once before you ever start looping over the numbers. So I have a system.out.println that prints a string inside the quotes that's n, and then some spaces, and then n times n plus 1. And that would display just that starting row. I made sure to put it before the for loop, because if I put it inside the for loop, then it would repeat every single time I displayed a new row of numbers, and that's not what we want. Okay, let's try the next one. So this question is just asking, do you know how to calculate an average? And what we're going to find the average of is we're going to find the average output from a run experiment method that we're imagining we already have. And I'm not showing you the codes. You don't actually know what the experiment is. But what you do know is that each time run experiment gets called, it will return an int as the output. So what our method is supposed to do is we're supposed to, in a loop, run this method over and over and over again, and then find the average output that all of these experiments give. How many times are we going to loop? Not 10,000. We're going to loop this many times, num trials. So here's a student solution. You see in the for loop, it's looping num trials times. And then inside each loop, they run the run experiment method. And they take the output from the method and they add it inside a sum variable. And a sum variable is initialized and declared up here as 0. After all the looping's done, we return the sum of all of the experimental outputs added together, divided by the total number of things that we added, which is the same as num trials, which is how many times we looped. So that in outline is how you can calculate an average, and that's a wonderful solution. Okay, let's do the last one. Here it's the same question, except instead of finding the average output from the run experiment method, we want to calculate a probability that the output is larger than 5. And the way we're going to calculate that probability is the same way, or very similar to how we did the average. Over and over and over again, we're going to run the experiment, and we're going to count how many times was the output larger than 5. And then we're going to divide that by the total number of experiments that we ran. That's the thing we're testing. It's that sort of conceptual idea for how you calculate an experimental probability. So here's the student solution. The student has written sum here, but it's probably not really right to think of this as a sum because we're not adding things into it. It's more like a count. We're counting how many times the output from run experiment was larger than 5. Other than that, everything's very similar. So the for loop is looping num trials times. we run the experiment, and if the output of the experiment is larger than 5, we add to the counter. And then at the very end, we divide the count for how many of the experiments had the output that we were interested in, and divide it by the total number of experiments we ever ran, which is num trials. So if you feel like this is a thing that you need to practice, it would be great after watching this video to just go right back and do it all again yourself without looking at the solutions, just to make sure you feel good that you can do it. I hope this was helpful.